Good morning, students. Students, this lesson is for class 8th for the subject of physics. Topic: some terms related to motion, which is covered in chapter 2, that is motion in one dimension, starting on page number 27 of your textbook titled Concise Physics by Selena Publications and is being submitted to you on 5th April 2021. Students, before starting our chapter, let us recap the definition of physical quantities, which we have already done in class 7th. Physical quantities are the quantities which can be measured, like mass, length, time, temperature, electric current, etc. All these quantities we have already learned in class 7th. So let us remember how these physical quantities are measured. So let us study what are the instruments required for the measurement of such physical quantities. Children, mass is measured using a beam balance. Length is measured using a meter scale. Time is measured using simple pendulum or a watch, while temperature is measured using thermometer. Electric current is measured using a device known as ammeter. Ammeter. Weight is measured using spring balance. Children, this year we will study that all physical quantities are broadly classified into two categories, namely scalar quantity and a vector quantity. Now coming to scalar quantities. These are the physical quantities which are expressed only by their magnitude. What are scalar quantities? The quantities which are expressed only by their magnitude. Magnitude means numeric value. So children, to express any scalar quantity, we need two things. Firstly, unit in which the quantity is being measured, and secondly, numerical value of the measured quantity. So we need a unit and a numerical value. For example, if we say mass is 5 kilogram, 5 is numeric value, kilogram is the unit, and mass is physical quantity. So mass is physical quantity, 5 is magnitude, kilogram is unit. So physical quantity, any scalar quantity, is represented by a unit and a numerical value. Now children, scalar quantities can be simply added, subtracted, multiplied, and divided using simple arithmetic methods, which we are already doing in mathematics also. simple addition, subtraction, multiplication, and division. Now, certain examples of scalar quantities are mass, temperature, distance, speed, work, energy, power, frequency, volume, electric current, pressure, density, charge, mechanical advantage. Children, all these quantities are mostly done in 7th, and we will be doing certain quantities in class 8th also. So till now you remember that all these quantities are scalar in nature. Children, mechanical advantage does not have any unit. It does not have any unit, and thus it is represented only by a numeric value. Similarly, pi, this you did in, this is a constant which is used in area of circle or a circumference of a circle. So the value of pi is 22 by 7, and we can approximately write it as 3.14. This is also a number. Pi is a number, and thus it does not have any unit. So pi does not have its unit, it has only a number. But it is a scalar quantity, and it is also known as scalar constant. Now children, suppose you purchase 2 kilogram of apple, and later you brought 1 kilogram of apple again. First you went to market and you brought 2 kgs of apple, and later you again purchased 1 kg of apple. So the net mass, the total mass of apple purchased by you is 2 plus 1, that is 3 kilogram. We have just simply added here. Similarly, if you finished your work in 20 minutes and then you took 5 minutes extra to revise that work thoroughly before submitting, then the total time taken by you to finish your assigned task is 20 plus 5 minutes. That is 25 minutes. So from these instances, it can be concluded that on scalar quantities, simple arithmetic methods can be applied, like we did simple addition in these two examples. Children, further we will study about very important type of quantity, that is vector quantities. Vector quantity is specified by giving magnitude, unit, and its direction. In scalar quantities, we were having only two things, magnitude and unit. While in vector quantities, three things are required, magnitude, unit, and direction. Now, for example, if we say that drive your vehicle 5 kilometers to reach hospital, then the first question which will arise will be, in which direction? I have just told you that you drive 5 kilometers and you'll reach hospital. Then the next question of yours will be, in which direction you have to drive? So children, this first statement was incomplete statement. But if we say that drive your vehicle 5 kilometers towards east to reach hospital. Now this statement is complete as it has direction associated with the magnitude. So 5 is the numeric value, kilometer is the unit, and east is the direction. So right now I have given you an example of a vector quantity. Now let us discuss some examples of vector quantities. Displacement, velocity, acceleration, force, weight, linear momentum, impulse, magnetic field. These are few of the vector quantities, and we'll be learning these vector quantities gradually as we proceed further in this chapter. Children, magnitude of any vector quantity is always positive. The numeric value, the magnitude is always positive. If we have to write force vector, then it is denoted by a symbol of an arrow above the physical quantity. So we will write down like this. F vector means an arrow. And this arrow has to be shown like this only, which is given in your PDF also. You cannot write down F with an opposite arrow or arrow placed at the bottom or parallel upward or downward. These all are incorrect methods. When you have to put a vector sign, you write down the quantity, suppose force, and then you put an arrow at the top of it. Now children, sometimes the negative sign with a vector quantity is also given, and it implies the reverse or opposite direction. For example, if I am saying that F force is applied along east direction, and if I write minus F, it means now the force, this negative sign means opposite direction. So opposite of east will be west. So this means that if a force of F is being shown in an east direction, it can be said as a force of minus F is applied along west direction. What I want to say is the magnitude of vector quantity is always positive. The magnitude of vector quantity is always positive, while this negative sign basically refers to east and west, opposite directions. Positive means a single direction, negative means it is opposite to the earlier direction. Suppose F vector was along west direction. Now minus F means the force is directed towards east direction. So further, note that vector quantities follows different algebra for their addition, subtraction, and multiplication, which you do in your higher classes. Now children, before starting further, let us revise certain terms which we studied in class 7th. The first term is rest. A body is said to be at rest if it does not change its position with respect to means as compared to its immediate surroundings. So a body is said to be at rest if it does not change its position with respect to its immediate surroundings. The next term is motion. A body is said to be in motion if it changes its position, if it changes its position with respect to its immediate surroundings. Now further coming to point particle. Children, for a moving body, if the distance traveled in a certain time interval is much large as compared to the size of the body, then the body can be assumed to be a point particle. Then we will study about one-dimensional motion. When a body moves along a straight line path, its motion is said to be one-dimensional motion. It is also called motion in straight line or rectilinear motion. For example, a stone falling down vertically and the motion of a train on a straight path or a track. Children, one dimension motion we did last year also under the chapter 2, motion. Note that in one dimension motion, there is no movement of the body in lateral directions. The word lateral means side. So there is no sideways motion because here either the object is falling down or it is moving in a straight path. It is not moving up down. It is not moving in sides. Coming to two-dimension motion, if a body moves on a plane along a curved path, its motion is two-dimensional motion. It is written as 2D also. So coming to three dimension, if a body moves in space, then its motion is three-dimensional motion. So students, in this chapter, we will be focusing on one-dimensional motion only. And with this, I come to an end of this interactive session. You all are requested to read page number 27 and 28 and then write the answers of question number 1 to 5 in your physics notebook. These questions are given on page number 35 of your physics textbook. Thank you, students.